Okay, so we have discussed the distance time graph and different cases in that kind of graph. So just like the distance time graph, we can also draw one more kind of graph, that is the velocity time graph. So in distance time graph, what we did is we plotted the time on horizontal axis and distance on vertical axis, just because the time is an independent quantity and therefore we need to plot it, or we need to plot the independent quantity on the horizontal axis. Now in this case also, try to judge that what quantity or which quantity should be plotted on the horizontal and which quantity should be plotted on the vertical axis. So you can see, just like the distance time graph, the time was on the horizontal axis, here also we will find that time is on the horizontal axis. Here also we will plot the time on horizontal axis and velocity on vertical axis. Okay, and this is on horizontal axis. Because the velocity is dependent on time, or velocity is a dependent quantity, that's why the time, or which is the independent quantity, it will be plotted on the horizontal axis. Now as we have seen in the case of distance time graph, we have three different cases. One was when body as it when the body is at rest, second was when the body is in uniform motion, and the third was when the body is in non-uniform motion. In case of velocity time graph also, we have multiple cases. So let's discuss the first case in the velocity time graph, and that case is when body is in uniform motion. When the body is in uniform motion. So when the body is in uniform motion, we call it as the constant velocity. Okay, when it is moving in a uniform motion. What is a uniform motion? When the velocity is constant, we call it as a uniform motion. Now let's take some example that how the object or the body is traveling. Let's say at t is equals to 0, the object was, let's say this is a ball, and I am considering this ball, I am observing this ball which is moving at some velocity. Let's say this ball is moving at some 10 meters per second speed. Okay, let us assume that at t is equals to 0, this ball is moving like this in a straight line, and I observed it that it is moving with the speed or velocity of 10 meters per second. Okay, now similarly at t is equals to 1, I observed that the same ball is again moving in the same direction and again with the same speed, that is 10 meters per second. Okay, I observed the same ball is moving with the speed of 10 meters per second in 1 second. Okay, after 1 second. Now when I saw this ball after 2 seconds, I observed that this ball is again moving at the same speed of 10 meters per second and in the same direction also. Okay, so what you can see, the speed of the ball and the direction of the ball is not changing with time. Okay, it is continuously moving in the same direction and also moving with the same speed. There is no change in the speed of the ball. So that's why we call it as velocity constant. Okay, or we can say it's a uniform motion. So let's try to plot the graph for this kind of motion. We will try to plot the velocity time graph of this type of motion. So how will we plot the graph? We will mark the time on the horizontal axis, time in seconds, and we will mark velocity on the vertical axis in meters per second. Okay, so this is the velocity in meters per second and this is the time in seconds. So let's try to plot the time. This is 1 second, this is 2 seconds, this is 3 seconds, this is somewhere here it's 4 seconds, and somewhere here it is 5 seconds, and this is 6 seconds, and so on. And if I talk about velocity, let's say this is 1 or let's say 5 meters per second, or let's say 2 meters per second, then 4 meters per second, then 6, then 8, and then 10. So I have just taken an example, okay. I have simply taken an example in which some object is traveling in some particular direction at the same speed. So what if this point is basically 0. So if I ask you what is the velocity of the object at t is equals to 0, what is t is equals to 0? The point at which I started observing the motion of this object, okay. So at t is equals to 0, or when I first saw this ball, okay, when you are walking on a road and you suddenly saw a truck or a vehicle, it is moving at some velocity. It's not like that when you start observing it, then only it start its motion. It's not like that. It is already moving from the past and moving with some speed, and when you observe it for first time, it is again moving with the same speed. So here also I consider, when I observe this ball for the first time, it is already moving at the 10 meters per second speed. So I will say at t is equals to 0, the speed of the ball is 10 meters per second, okay. Now what happened after 1 second? After 1 second, the again ball is moving at the same speed. So at 1 second as well, I will mark a point like this, somewhere like this, and this is the point at 1 second. What will happen after 2 seconds? Again, after the 2 seconds, you will find the position or the speed of the ball is 10 meters only, okay. So it is again moving with the 10 meters per second speed, and this is the time, that is 2 seconds. What will happen after 3 seconds? The ball will again going to move with the same speed. There is no change in the speed of the ball, so it is moving again with the same speed, that is 3 seconds. What will happen after 4 seconds? The ball will again be moving with the same speed of 10 seconds, and so 10 meters per second, and so on. And if I join this line, this will come out to be a straight line, okay. Every second, if I start counting till infinity, the graph, this line will going to extend till infinity. So what I can say, when the object is moving with the uniform velocity, or when the object is in uniform motion, its velocity time graph will be a straight line, okay. So let's write this complete conclusion. So when an object is in uniform motion, its velocity time graph will be a straight line. Now what kind of straight line it is? You can see this straight line is parallel to the horizontal axis. So we will write, when an object is in uniform motion, its velocity time graph will be a straight line parallel to x axis, okay. You can see this graph is parallel to x axis. So we will find this kind of graph when the object is moving with the uniform velocity. Now what is the importance of this graph? Basically, what kind of conclusions we can draw from this graph? One we can draw is, when you see a velocity time graph like this, you will clearly say that the object is in uniform motion. You need not to calculate anything or solve anything or perform some mathematical operation. You just, by observing this graph, you can say that object is traveling with the uniform velocity, or the object is in uniform motion, okay. When the velocity time graph is like this, okay, don't get confused with the distance time graph. When this is the curve for distance time graph, what we have seen, in case of distance time graph, when the graph is like this, this represents the object is at rest, or the object is at stationary position, okay. The object is stationary, okay. So don't get confused with the two cases. We can see the graph is just exactly same, there is no change in the graph, but the quantity is changed. Here we have velocity time, in that case we have distance and time. Okay, so please remember this. In case of velocity time graph, a parallel line to the horizontal axis, it will give you uniform motion. Okay, in case of distance time graph, a line parallel to horizontal axis will give you the stationary object. Okay, so one conclusion that we have drawn, that this straight line suggests object is in uniform motion. Now let's try to draw some more important conclusions. Okay, let's try to draw this. What we can see, since the object is in uniform motion, its velocity is not going to change till infinity. Okay, if it continuously moving in the same direction, it will going to move in the same direction with the same speed, with the and that is, there is no change in the velocity. Okay, or its velocity will remain constant throughout its motion. So if I assume a time, let's say if I assume a time somewhere here, let's say this is t1, I assume a time t1 at somewhere here, what would be the velocity of the object at this point t1? I will say the velocity of the object at this point t1 will remain this only. Okay, will remain this only. Let's say this velocity is basically v. Let's assume that this velocity is v. We considered it as 10, but now let's consider this as velocity v at point t1. Okay, now since it's moving with the uniform moving in a uniform motion, what would be its velocity at some other time t2? If I ask you its velocity at some other time t2, what would be its velocity? We can see the velocity at t2 will be again v only. Okay, velocity at t2 will remain v only. Okay, so we will write here, let at time t1 velocity is equals to v, then at time t2 also velocity will be equals to v only, that is v meters per second or v only, just because the object is in uniform motion. So here we write it in the bracket, because object is in uniform motion. Okay, the object is in uniform motion, that's why the velocity will remain constant. Now when we draw these two lines, try to observe this graph. Okay, try to observe this curve. Okay, try to observe this. Let us assume this is point A, this is point B, let's say this is point D, or let's say this is C, and let us say this is point D. So these are the 4 points A, B, C and D. Okay, we have marked this. Now what kind of figure is this? This is basically a rectangle. Okay, this is a rectangle. Now if I ask you to calculate the area of this rectangle, how will you calculate the area? You can see area of rectangle ABCD will be equals to what? How will you calculate the area? Area of a rectangle is length into breadth. Now what is length? Length is this AD and breadth is this DC, or you can say AB. So I will say AD is the length and DC is the breadth. So area of the rectangle will be AD into DC, that is length into breadth. That is length into breadth. This is the area of the rectangle. Now if I ask you what is the length of this AD, So you can see the length of this AD is basically this much, okay, and how much this is V, okay. So length of AD is basically V. So length of AD is equals to V, or V units, we can say V units. Just calculate this length by using a ruler. You can see this is V. Now if I ask you the length of DC, see, O to C is T2, this is T2, this complete length is T2, and O to D is basically T1. So the length of DC will be T2 minus T1, okay. Just observe this, length of DC will be this much length is this complete length minus this complete length, okay. So if I subtract from this length, if I subtract this length, I will get DC. So I will say the length of DC is basically T2 minus T1, that is T2 minus T1. So if I multiply AD and DC, where AD is V and DC is T2 minus T1. Now observe this. Now this is a very important conclusion. What is V? V is the velocity, and what is T2 minus T1? It is the time, okay. So velocity into time. So we are getting a result of velocity into time. Now what is velocity into time? Just try to recall what is velocity into time. We studied a very important conclusion, we studied a very important equation, that velocity is basically displacement upon time. Now this can imply that displacement is equals to velocity into time. So I will say that when you multiply velocity and time, this will give you displacement or distance, okay. In a simple language, I will say that velocity into time is basically displacement. This is a very important rule. Velocity into time will give you the displacement. Now since here I am getting velocity into time, so what should this product should give me? It will give you the displacement in this particular region, okay. So this particular combination, that is V into T2 minus T1. What if I multiply V into T2? This will give you the complete region. What is V into T1? This will give you the small region. But what is V into T2 minus T1? That is this region. So V into T2 minus T1 will give you the distance travelled or the displacement in the interval T2 minus T1. So what I will say, that this particular expression V into T2 minus T1, this will give you the, this is the displacement or the distance travelled in, or the distance travelled between T1 and T2. So in the time duration from T1 to T2, we have travelled this much distance, okay, that is V into T2 minus T1. Now basically what is this? This is the area of this particular rectangle. So what I can say, that area of ABCD is equals to V times T2 minus T1, that is distance travelled from T1 to T2, or in this duration of T1 to T2, how much distance we have travelled, we can calculate using this area. So very important conclusion that we can draw, and what is that? We can draw a very important conclusion, that is the area of velocity time graph gives you the distance, okay. So here I will write the conclusion, the area of velocity time graph will give the distance or displacement. Now this is the biggest conclusion, this is the most important conclusion of this kind of graph, that is velocity time graph. You just need to calculate the area of velocity time graph and you will automatically get the total distance or total displacement of the object. Okay. So in this way, this is the physical significance of velocity time graph, that as we have seen in the distance time graph, the ratio of or the division of the distance and time gives you the velocity. Here we can see the multiplication of velocity and time will give you the distance. Okay, this is just the using this formula we can very easily observe this. So this is the most important conclusion. Velocity time graph will give you the distance. Okay, the area of the velocity time graph, and the division of distance and time will give you the velocity in the case of distance time graph. But here we are talking about velocity time graph. Okay, so this is the most important conclusion. Okay, so you note this first condition of uniform motion of the object. Now we will draw, after this we will draw how the graph of an object which is traveling in the non-uniform motion, how its velocity time graph is look like. Okay, so you will understand that concept. First you note this. Okay.